So this is FM-202, nature of flow. So we have water in an overhead tank which comes down to the first tank. The water from the tank 1 flows to tank 2 via the pipe, and there is an outlet valve at the end of the second tank from which the water flows out. So initially the outlet valve from the second tank is closed so that the water in the system is stagnant. Also we observe that there is a funnel in the first tank so that the water coming from the overhead tank is not overflowed and it is drained to the reservoir. So in our experiment we open the outlet valve and take 3 readings corresponding to flow rates of laminar flow, 3 readings corresponding to transition flow, and 3 readings corresponding to turbulent flow. Also, in each case we put a stream of ink inside the pipe so that we can observe the behavior of water flow inside the pipe for each case. Also, our experiment deals with verifying the correlation of Reynolds number and friction factor. So for Reynolds number, we collect the water from the outlet valve in a fixed amount of time using a stopwatch, and also to find the friction factor we need the pressure difference, which is nothing but the rho g into height difference. So we have to find the heights of the 2 tanks. This is done using a measuring scale and the Z transverse micrometer. When the valve is closed, the height levels in the 2 tanks are the same because there is no pressure difference. Now we open the valve slightly. Now we see that the water is flowing from the tank to the bucket, and we'll also see that when the system reaches a steady state, the height in the second tank will reduce. So what we have to do is we wait for 2 to 3 minutes for the flow to stabilize, and then we collect the water using the measuring cylinder and the stopwatch. So after this we know the time, it is 29.81 seconds, and the height of the water collected, so this is 1620 ml. So we measure the height of the water level in the first tank using a so we observe that the height is 47.1 centimeter. Also the use of the Z transverse micrometer is such that we rotate the knob, the Z transverse micrometer, such that the tip of the device just touches the water level. So we see now that the tip has just touched the water level, and now we take the reading corresponding to the distance from here. In the same way, we measure the height of the second tank using the measuring, and you observe that the height is 46.1 centimeter. Also we see that the water level has decreased, and so we rotate the knob again till a point that the tip will just touch the water level. So we see now again that the tip has just touched the water level, and we take the corresponding reading from here. Heights of the 2 tanks, we can find a delta H, and thus we can find a delta P, which is the pressure difference. Using the pressure difference we can find the friction factor. Also using the flow rate we can find the velocity and hence the Reynolds number, and taking 10 such readings we can verify the correlation between the Reynolds number and friction factor for this different flow regimes.